Welcome to this explainer. If you're gearing up for the Cisco AI Technical Practitioner certification, specifically Section 2.0 of the 8-10-110 exam, you are in exactly the right spot. We aren't just chatting with AI today, we're talking about systematically engineering its behavior and, crucially, locking it down against malicious attacks. So here's our game plan for today. We'll start with the anatomy of prompts, then move right into advanced prompting techniques. After that, we'll look at the dark side with prompt injection attacks, and finally, we'll wrap up with defensive prompting mitigations. Okay, let's dive right into part one, the anatomy of prompts. Listen, as an AI technical practitioner, you know prompt engineering isn't just casually firing off questions into a chat box. It's a rigorous engineering discipline. The Cisco syllabus really hammers home that mastering these principles means applying three core things: roles, instructions, and constraints. Basically, you've got to give the model a specific persona, hand it a crystal clear, unambiguous task, and then box in its behavior with hard limits. Just think about the difference between a naked instruction and an engineered prompt. If you just tell a model, write code, well, that's essentially a runaway train. The AI has to guess your intent, the programming language, the formatting, everything. But when we apply those three core principles, it's a completely different story. You assign a role like senior developer. You give a strict instruction like write Python code, and you add a constraint, limit to 10 lines. Boom, engineered boundaries. It is hands down the fastest, most reliable way to elevate and standardize AI performance in any enterprise environment. All right, that brings us to section 2, advanced prompting techniques. Now, if you try to shove a massive, complex task into a single instruction, it's probably going to fail, right? Instead, the syllabus highlights using chain structures. You start with an initial sequential input, the model chews on that, and then you actually use its output to feed your next prompt. You're building a chain of reasoning. The step-by-step guidance stops the AI from losing context, and it forces it to basically show its work before giving you that final contextual output. As a practitioner, it's all about picking the right tool for the job. Let's compare two really critical techniques here. First up is iterative prompting. This is a conversational back and forth where you're refining the outputs over multiple turns. It's absolutely fantastic for exploring ideas or debugging code. Then you have few-shot prompting. This is when you drop 2 or 3 highly accurate examples of the input and output directly into your prompt right up front. You use few-shot when you need the model to instantly nail a very specific format or tone. No back and forth required. And here's something really important to keep in mind. The Cisco AI Tech syllabus stresses that these advanced structures aren't just for large language models spitting out text. Not at all. Assigning roles, instructions, constraints, and using few-shot examples, those are just as critical for accurate image generation, like with diffusion models, and even advanced audio generation workflows. The core engineering mindset literally stays the exact same across all modalities. Now things get a bit more intense. Section 3, prompt injection attacks. So ask yourself, can your meticulously engineered AI workflow be completely hijacked by a single rogue sentence? The terrifying answer is yes, absolutely. This is the reality of prompt injections, and they're a massive security threat to everything we just learned how to build. Think about it. If a user types in text that the AI mistakenly interprets as a brand new system command instead of just conversational data, your entire architecture crumbles. The crucial point here is understanding the specific types of attacks we're up against. Prompt injections directly attack that holy trinity we talked about earlier. Attackers will use malicious inputs to completely bypass your carefully crafted constraints. They'll write prompts designed to override the model's assigned role, like tricking your friendly customer service bot into generating malicious code. They hijack instructions entirely. And ultimately, this leads to severe data exposure risks, where the model gets tricked into leaking proprietary company data or sensitive conversational history. It's a huge deal. Which naturally leads us into Section 4, defensive prompting mitigations. Defensive prompting is essentially your dual-purpose shield. It doesn't just block those malicious human hackers, it also fixes organic model failures. On one side, you have AI-generated errors, most notably hallucinations, where the model just confidently invents false information. On the other side, we have our mitigations. We can engineer our prompts with incredibly strict output boundaries and explicit fact-checking constraints. For instance, literally telling the model, if the answer is not contained in the provided text, reply with, "I do not know." That one defensive constraint stops both hallucinations and rogue injection attempts dead in their tracks. But writing good text constraints is only half the battle. To genuinely secure an enterprise AI system, you have to tie these technical mitigations into the broader governance and security mandates of the Cisco syllabus. We're talking about integrating real AI governance, putting strict policies and risk management frameworks around token usage and model access. It means setting up human-in-the-loop, or HITL strategies, ensuring an actual human reviews critical AI outputs before they ever go live. And above all, it means architecting rock-solid controls to enforce corporate data privacy, making sure your sensitive information never accidentally ends up in a public model's training set. I want to quickly remind you why all of this is so vital for your career right now. The AI landscape is shifting incredibly fast, but the foundational ability to engineer a robust prompt and secure it against manipulation, that's not going anywhere. Mastering this delicate balance between architectural design and defensive security is absolutely key to succeeding on the Cisco AI Technical Practitioner exam. As we wrap up this explainer, I want to leave you with a final thought, coming at this from the perspective of an engineering mentor. Look, getting a cool output from an AI model is easy, but true AI mastery, it isn't just about building the most complex prompt out there. It's about engineering an architecture resilient enough to defend itself. There's an ongoing arms race right now between prompt execution and AI security, and your job is to stay one step ahead on that battlefield. So, I'll leave you with this one critical question to think about. How will you fortify your next AI workflow? Take those roles, instructions, and constraints you've learned today. Anticipate the injection attacks, and go build something brilliantly secure. Thank you so much for joining me on this explainer, and keep on learning.